An important application of determinants is the solution of linear simultaneous equations, which is called Cramer's rule. First we take up solution of set of two linear equations in two variables. Let a1x plus b1y equal to d1, a2x plus b2y equal to d2. Also let d equal to the determinant form by the coefficients, that is d equal to a1, a2, b1, b2 as columns. Its value is a1, b2 minus a2, b1. We assume that it is not 0. So consider d1 equal to as the determinant formed by first column d1, d2, second column b1, b2. It must be noted here d1, d2 are replacing the coefficients of x, a1 and a2 in the determinant d. So replacing d1, d2 by its values, that is first column becomes a1x plus b1y and a2x plus b2y. Second column is b1, b2. Now operate. C1 goes to C1 minus y times C2. We get d1 equal to a1x, a2x, b1, b2. Pulling out x common, we get x times a1, a2 and b1, b2, which is equal to x times d. So therefore, x is equal to d1 upon d. Now consider d2 similarly equal to a1, a2, first column, d1, d2 as the second column. Here we have replaced the coefficients of y by the right hand constants. The determinant becomes a1, a2, and we have put the values of d1, d2 as a1x plus b1y and a2x plus b2y. Operating, C2 goes to C2 minus x times C1. We get d2 equal to a1, a2, first column, b1y, b2y in the second column. Pulling out y common from the column 2, we get y times a1, a2, b1, b2, which is d. Therefore d2 is equal to d times y, and y is equal to d2 upon d. The solution is x equal to d1 upon d and y equal to d2 upon d, where d is equal to the coefficient, the determinant formed by the coefficients, that is a1, a2 in the first column, b1, b2 in the second column, and d1 equal to d1, d2, and in the first column b1, b2 in the second column, and d2 equal to a1, a2 in the first column, d1, d2 in the second column. Thus, if d is not equal to 0, it has a unique solution. Next we take up the solution of a set of three linear equations in three variables. Let a1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z equal to d2, and a3x plus b3y plus c3z equal to d3. Here we let d equal to a1, a2, a3 in the first column, b1, b2, b3 in the second column, c1, c2, c3 in the third column. D1 equal to D1, D2, D3 replaces the column of coefficients of x, that is A1, A2, A3 are replaced by D1, D2, D3. The next two columns remain same, that is B1, B2, B3 and C1, C2, C3. Similarly, D2 is obtained by replacing the coefficients of y by the constants D1, D2, D3. Hence, D2 equal to A1, A2, A3 as the first column, D1, D2, D3 as the second column, C1, C2, C3 as the third column. Similarly, D3 is equal to first column A1, A2, A3, second column B1, B2, B3 and the third column is D1, D2, D3 which replaces C1, C2, C3.